Write this question in your composition book and answer it. So how are compounds formed? They're formed during chemical changes, which are also called chemical reactions, and these chemical changes are represented by chemical equations, which happens to be the title of our notes, chemical equations. We've already learned that compounds are represented by chemical formulas. You should also remember that chemical formulas show how many and what kind of atoms make up the compound. For example, in the compound H2O, this tells us that one molecule of water contains 2 hydrogen atoms and 1 oxygen atom. Every molecule of water is going to contain this ratio of hydrogen and oxygen atoms. And let's look at this one. For barium hydroxide, this tells us that there is 1 barium atom. This little 2 right here is outside the parentheses. And in math, when we have a number outside the parentheses, we have to distribute. So the 2 gets distributed to everything in the parentheses. So that tells us there are 2 oxygen atoms and 2 hydrogen atoms. Hopefully y'all remember this from the 8th grade. Some key things to remember is that chemical changes are represented by chemical equations, and a chemical equation is a type of chemical sentence that shows what happens during a chemical change. Now, during a chemical change, mass must always be conserved. That means however many atoms I started with, that's how many I have to have when I'm done. And whatever kind of atoms I started with, that's what kind I have to have when I'm done. Now, because of this, chemical equations must always be balanced. So we're going to look at how to balance chemical equations. That simply means that the number and kind of atoms on each side of the equation must be equal, and we're going to look at this equation as our first example. Alright, let's count how many atoms there are on each side. That's called an atom inventory. There's 1 sodium over here. There's 1 chlorine. And how many oxygens are there? There's 3. Now, write those same elements on the other side in the same order. According to this, I have 1 sodium, 1 chlorine, and 2 oxygens. So is this equation balanced? No, it's not, because the oxygens are not the same on each side. The sodiums and the chlorines are. I have 1 sodium on each side, 1 chlorine on each side, but the oxygens are out of balance. So this equation is not balanced. Let's look at what we need to do to balance it. On the left side of the arrow is our dividing sign in an equation. These things are called the reactants. And on the right of the arrow, we have products. Reactants are the substances present at the beginning of a chemical change. The products are the substances produced by a chemical change. Okay, let's look at the steps for balancing an equation. First is to perform an atom inventory, which we had done on the previous slide, so let's do that again. We have Na, Cl, and O on each side. Put them in the same order on each side. On the left, I have 1 Na, 1 Cl, and 3 oxygens. On the right, I have 1 sodium, 1 chlorine, and 2 oxygens. For each element that is not balanced, it says to find the least common multiple. Well, this one is balanced, and so is this one. So that leaves me the oxygen to look at. Well, the least common multiple with the oxygens is 6. That's the smallest number that 3 and 2 will both divide into. Okay, step 3 says to use the least common multiple to place coefficients in front of the chemical formulas to make the elements balance. Well, the least common multiple tells me that I need 6 atoms. So in order to get 6 atoms on the left, I'm going to have to take this 3 and multiply it by 2. So that means I've got to put a 2 out here in front of the chemical formula that contains the oxygen. And then on the right, I have to multiply this by a 3 to get 6. So I put a 3 in front of the chemical formula containing the oxygen. And number 4 says to do a new atom inventory. So let's do a new atom inventory. Now I have 2 sodiums, 2 chlorines, and 6 oxygens on the left. I still have 1 sodium and 1 chlorine on the right, but now I have 6 oxygens on the right. Now my oxygens are balanced, and these aren't balanced. So what's my last step? My last step says to repeat steps 2 through 4 until each element is balanced. So let's look back at the sodiums. Sodiums are not balanced. The least common multiple for sodium is a 2 now, which means I need 2 atoms of sodium. I already have that on the right. I need to multiply that by 2. I mean, on the left I already have 2. On the right I would need to multiply that by 2 to get me 2, so I'm going to put a 2 in front of the Na. Now I do a new atom inventory. I didn't change anything on the left, so those are all still 2, 2, and 6. But now on the right I have 2 sodiums and 2 chlorines. Didn't change the oxygens, that's still at 6. Oh look, now my sodiums are balanced, and my chlorines are balanced, and my oxygens are balanced. So I'm done. 2 things to remember when you're balancing equations. You absolutely cannot change the subscripts. The subscripts are these little numbers right here. You don't get to change those. And you cannot add new formulas to the chemical equation. You can only balance what's already there. Okay, let's do another example. The first step is to perform an atom inventory. So let's do that. We have Zn, H, and Cl on each side. On the reactant side I have 1 Zn, 1 H, and 1 Cl. On the product side I have 1 Zn, 2 H's, and 2 Cl's. That was step 1, perform an atom inventory. Step 2 says for each element that is not balanced, find the least common multiple. So let's pick one. It looks like zincs are balanced. Hydrogen is not balanced, so let's find the least common multiple for hydrogen. So the least common multiple is 2. That means I need 2 hydrogens on each side. I already have 2 hydrogens on the product side. So on this side I've got to multiply that by 2. So that means I need to take that 2 and put it in front of the chemical formula that has the next step, number 4, because we did number 3, use the least common multiple to place coefficients in front of the chemical formulas. Number 4 says to perform a new atom inventory. So let's do that. We didn't change the zinc on the reactant side. We did change the hydrogen. So now instead of this, we have 2 hydrogens and we have 2 chlorines. Step number 5 says to repeat until each element is balanced. It looks like the zincs are balanced, the hydrogens are balanced, and the chlorines are balanced. So we're done. Okay, one more example. Step 1 is to perform an atom inventory. We have hydrogens. We have 2 of those on this side. Now we have sulfur and oxygen here, but if you'll notice that's SO4, which is one of our polyatomic ions. It's also in the form SO4 on the product side. So if a polyatomic ion is in the same form on the reactants as it is on the products, then we leave it together and count it as one thing. There is 1 sulfate on the reactant side. And then we have iron as well, Fe, and there's 1 of those. So now let's do the product side. We have H, we have SO4, sulfate, and we have iron. There are 2 H's, and according to this, there are 3 sulfates, and there are 2 irons. Now I choose an element that's not balanced, and I find the least common multiple. The first one is sulfate. It's not balanced, so let's balance it. The least common multiple for the sulfate is 3. So I need 3 sulfates on each side. I have 3 on the product side. I need to multiply this by 3 to get 3 on the reactant side, so I'm going to put a 3 in front of the chemical formula containing the sulfate. The next step is to perform a new atom inventory. Well, I don't have 2 hydrogens on the reactant side anymore. I have 6. And now I have 3 sulfates, and I still have just the 1 iron. I didn't change that. I didn't change anything on the product side, so that's all fine. Okay, everything is still not balanced. So let's look at our elements that aren't balanced, and Fe is next on our list. We balanced the sulfates. Least common multiple here is 2. I have 2 on the product side. I need to multiply this by 2 to get 2 on the reactant side, so I'm going to place a 2 in front of the chemical formula containing the iron. Okay, new atom inventory. All I changed was the Fe, so that's now a 2, and those are now balanced. Looks like the only thing left that's not balanced is the hydrogen. The least common multiple here is 6. I already have 6 on the reactant side. I need to multiply this by 3 to get 6 on the product side. So I put a 3 in front of the chemical formula containing the hydrogen. Perform a new atom inventory. This is the only thing that I changed. So that's the only thing I really need to count. I now have 6 hydrogens there. And voila, the hydrogens, the sulfates, and the iron are now all balanced.